Welcome to the KEI Network's webinar, Just a Chat about the future, the impact of nuclear fusion for energy. Energy is relevant to everyone. Yes, everyone on Earth. Energy is the world's largest multi-trillion-dollar economy and central to the world's geopolitical balance. Energy, we need it. Energy, we consume it for power or heat, and we produce and distribute it for fueling the economy. There are few places on Earth where the energy is as relevant as it is to Alberta. Alberta is a geopolitical force in the world's energy economy. It's a major producer and distributor of energy, so much so that energy, namely Alberta's oil and gas industry, is central to both Canada and the United States economies. Alberta is also, like the rest of Canada, a major consumer of energy, given our environment. So it comes as no surprise that this week's announced, quote, breakthrough in fusion energy would attract your interest. What does come as a surprise, to me at least, and hence the subject of today's discussion, is that there is so little discussion about fusion for energy and the future. That is just what to expect in terms of the social, economic, and geopolitical impacts when fusion is realized. I cast this question out to you in the network on Wednesday, and that was, what will be the impact of energy abundance, clean and safe, accessible and affordable energy, as promised by fusion advocates? Most replies address the timing and technical challenges, the science and engineering of fusion. Few addressed, to my disappointment, unless prompted, the socioeconomic and/or geopolitical implications of fusion on people and politics. And so let's begin. First, with a brief introduction about what is fusion, and then open up discussion about the future, the changes we might anticipate when fusion for energy is available and accessible, and as promised, clean and safe. I've asked Dr. Allan Offenberger to join us. He's a professor emeritus from the University of Alberta, world-renowned for his research, co-founder of the Alberta Canada Fusion Alliance, now Fusion Energy Council of Canada, and a passionate advocate for the development of fusion for energy. And he also likes Scotch. Allan, just what is fusion? Why so much excitement about this breakthrough? And what do you see as the impact of it serving as a source of energy? Over to you.
Okay, well, just before I answer the question and say a bit, let me explain to you how it is that I'm here and why I am both excited and realistic about what's been happening. In fact, I got started very early. I was in my senior undergraduate days at UBC when the laser was invented, for one. And I spent a summer with the Defense Research Board in Ottawa in the basement of the building. They were building the first Alouette satellites. So I'd go down and check on them every morning. But in the afternoon, working in the lab, I got to listen to 3 weeks of lectures by Bill Thompson, a professor at Oxford, who'd been over to give a series of talks on communications.
Oh, you got muted, Allan. Allan, there you go.
Yeah, am I not coming through?
You were just muted for a minute. I was muting somebody else, and my screen jumped.
Anyway, so it goes back to that early 60s period. And then lo and behold, I went off to MIT to do my doctorate, and I got involved with lasers and plasmas and fusion. And of course, you may have heard that MIT is one of the hotbeds of technology that's now spinning out into what's called Commonwealth Fusion Systems in Massachusetts, using the magnetic confinement approach. Anyway, that's just to say that I've been around since the very beginning, and consequently very excited to see what's emerging. Let me turn now to the current, and I'm both excited and realistic. Given that it was characterized a long time ago when I was a student that fusion would be the toughest technological nut that mankind would ever try and break open, and it's proven to be that. It's taken a lot of decades of learning to get to where we are. Nonetheless, the payoff so fabulous that mankind has been working very hard since the 50s to try and achieve that state on the face of the earth to create energy. It's been a long learning curve. We've got the science, we've got the technology, we've got the computational, we've got all the enabling technologies. It's been a very long learning curve, but in fact, this has been a scientific triumph. And we shouldn't look at the results mentioned yesterday other than that. It is not fusion energy. It is a scientific triumph to create the conditions for liberating fusion energy as the experiment at Livermore has demonstrated. And you're going to see within a short time similar results from magnetic confinement and other approaches. So these initial ones, just take them as great scientific information. The question of what we do with it thereafter is still a long ways away. But we are at the point where we are now transitioning from science to engineering, and in the near term, commercial application. And let me just pick up on a few things there to amplify on that. As you recognize, given, and I'll use the word hype that's emerged in the last few days, given the hype attending it, this attracts interest, and we need interest because fusion is going to need a lot of investment to get us to the payoff. So take it as scientific triumph, take it as here's your cue to get out and start spending money to really develop it for energy production. So that's all positive. What we don't need, though, is an underlying message that, hey, if we go out and spend some money today, next year we're going to have the results. That's not going to happen. So we've got to be realistic about it. Nonetheless, that achievement is now stimulating investment. In fact, the investment's been going on for a few years. There's over 36 companies in the world at large that have said, look, on the basis of what the knowledge base is, all funded by governments around the world, the entire knowledge base has come out of government funding. Nonetheless, deep pockets are putting money into private ventures to start looking at ways and means to see this transition to practical energy sources. And there's a whole variety of different approaches that people are taking, and we can get into some of them later if you want. I'll just highlight that there's a multivariate way of approaching it, and there's going to be more than one way that succeeds. So you can feel confident that people are not going to be spending money in vain. We're going to see success coming out of this. The issues are when you've got the scientific base, how do you translate it into the issues of reliable, robust production of energy? And I'll mention sort of 3 key things that will make that possible. One of them, and very importantly, it's going to be the question of materials. If we don't have the right materials, we're not going to be able to keep these things running, because the environment in which fusion takes place is so hot and the particles coming out can interact with the material around it that to have it sustainable and maintainable, we're going to need a lot of development in materials. Secondly, there's the issue of the fuel supply. In the first instance, deuterium, one of the key fuels, that we can mine out of the oceans and the land. We'll never run out of deuterium. We've literally got billions of years of fuel. But the other fuel we want, at least in the inertial stages of making fusion work, is tritium, another isotope of hydrogen. And that just naturally decays away. So the bit of tritium that mankind produces on the face of the earth, a big source, in fact, is our heavy water reactor, the CANDU heavy water reactor, because it has deuterium as a moderator. When the neutrons interact with that, it produces tritium. And so Canada is the one sort of big reliable supplier of tritium, but it's not very much. So we need tritium fuel, and we need to be able to use tritium fuel efficiently, or we'll never get the commercial payoff. So materials, tritium fuel, 2 important things. The third thing is that fusion, unlike past big power plants that tend to be one-off constructions with a lot of concrete and piping and so on, fusion is going to be the first system to come along that's going to be manufactured components, trucked to the site, implemented, line replaceable units, a lot of robotics and artificial intelligence running the whole thing. It's going to become a very highly automated way of doing things. So obviously there's got to be a lot of running up in the knowledge base of how you put all those engineering technologies to work to give you the sustainable maintenance. So that's where the work is going to go. We have conceptual ideas of how to put pieces together in order to make those initial demo, call them demo units. But the key things going into it, materials, tritium fuel, handling, these are the things that will have to be constantly revised and improved upon as we go forward. Let me say why I'm excited about that this is not going to take decades and decades, but it's going to take more than one decade. Although the initial proponents going out and spending money now, and it's into the billions, the initial investment, are saying we'll do it within 10 years. And in fact, you may or may not know, fusion is embedded in energy policy in Europe and Asia, but it has not been in North America. But that has changed in the US. So Canada is the only developed nation left over that's not involved with this policy decision so far. But the US just recently changed it around very significantly. In fact, the White House convened a series of meetings to amplify where we're going. They've appointed a coordinator to engineer the private public sector development. They've said we want a commercial demo in 10 years. We'll see what can be done. When the US turns things on in a big way, things can happen pretty quickly. So they have declared a 10-year time frame in an official capacity, but it's going to take a lot of investment and work to prove that out. But if it's 10 years or 15 or 20, doesn't really matter. It's near term, we're going to see it. And why is that? Because once you've got the scientific base established and the money starts pouring in, the private sector is going to speed up the development in an enormously productive way. So it's the fact that the private sector is now engaged. We're going to see very rapid development compared to what has been a learning curve for the last few decades of knowledge acquired. What else might I add before we get into sort of question discussion? There's the different approaches. We can talk more about them in detail, but at the two extremes, we have what are called magnetic confinement and inertial confinement. Inertial meaning that you don't confine it at all, you let it blow itself apart and catch it on the run. The magnetic confinement, you work with very much lower pressures and you try and bottle it into a magnetic confinement geometry. And in between those two extremes, you have a wide variety of approaches that vary different parameters. And the three main parameters we're concerned about is the density of material, how many particles per unit volume are in that chamber, wherever reacting. The temperature, we have to have a minimum temperature to get ignition to make it work. And we need to confine it long enough that there's a net energy out over what you had to invest in the first place. And that's what this significant ignition event is all about. You got more energy out than you had to invest in the plasma in the first place. So given that you've got those three parameters, that gives you a lot of space to work. You can work with low density, high density, change the temperature a bit, change the confinement time, long and short. So the world is actually pursuing a number of variations in that parameter space to try and find their niche and ultimately then a commercial workable system. I'll just highlight two in the sense I've already commented on, mentioned Commonwealth Fusion Systems in Massachusetts. That came out of the very high magnetic field technology that has been developed at MIT over the years. And the key thing is, it turns out if I want to scale up these devices for magnetic confinement, it tends to scale up with a very high power of the magnitude of the magnetic field. So if I have to work with a magnetic field of call it unity, and I can double it, I can end up going up about 8 times in the volume improvement, or make it 8 times smaller for the same performance. So there's a very big scaling factor with magnetic field. What MIT has done is brought out and established that they can produce a reliable coil with a magnetic field about 2.5 times bigger than anything that the world has built for all the tokamak-like devices that have been built around the world. And there's been literally hundreds of them over the years. Well, if I can scale a factor of 2.5 cubed, I've got a very large number working for me in terms of the size of the device. So they're imagining then much smaller and therefore more commercially attractive magnetic confinement devices. And they're building the facilities now in Devens. That was a US Army camp just west of Boston. They've got that property now. They're building a place to produce these magnets and a place to build the tokamak geometry of the devices to demonstrate this. They're looking to do a demo in 5 years, and they want to see energy production on the grid in 10. So you can see what, but you've got a lot of horsepower there. You've got the big Gates and Bezos and Koshla. You've got ENI, the Italian oil and gas company. There's a lot of very big money going into that activity in Massachusetts. So look for them as one of the signal approaches. On the laser side, there's several ways proposed around the world. And I'll just mention one that I happen to be involved with. It comes out of technology that, in fact, we were involved in developing back 40 years ago here at the University of Alberta, based on krypton fluoride lasers. And this company in the US, out of work that was done under SDI in the US, the Strategic Defense Initiative, back in the Reagan years, and other academic work, they have come up with a scheme based on krypton fluoride lasers that I'm now involved with as an advisor. And it's probably the one that I have the most confidence in as a way forward on the inertial approach. The Livermore approach, remember that one, that was built with very old laser technology, very inefficient, and it wasn't meant to do anything other than scientific investigation. It was never setting out to become a fusion energy device. It was strictly a workhorse tool to do the science of actually simulating fusion for the US nuclear weapons program. But it turns out to be important as the spinoff that can come too. Anyway, if you're going to go out and do laser fusion, you do not want to do it the way Livermore did it. You want to start and approach it in a different way. And I'm saying here's a company that, in fact, I think has a potentially fruitful way to go forward that will simultaneously tackle the materials issues, the tritium, the power handling, the recycling, all the pieces. So it's encouraging to see that there are some good ideas out there. And there are others that we don't have to get into all the details. But it's to say there's some bright, creative people with some commercial instincts as to how to harness this and move forward. So I'm pretty optimistic about how quickly we're going to see some of this progress achieved.
Excellent.
Well, let me take a break there and let others ask questions and discuss. And
Well, much of your focus, Allan, of course, is on production. And I want to turn the conversation in a few moments over to consumption, which is the market, and how fusion would make our lives different, as opposed to a discussion on production itself. But since Allan is with us just now, and I know, Mel, you had to leave, but if Mel is still about, Mel, is there a question or two or a comment you want to make relative to the production side of the discussion?
Yeah, not so much with the production side of it. I've done a fair amount of reading on that. Of course, professionally, have not been involved in fusion at all, like most of us here. But I have a reasonable understanding of the process. And my concern, really, having watched the news release the other day, and even some of the stuff I read in the media, is that the science community has much difficulty in explaining what this is all about, what the benefits are. That, yeah, Tritium's got a half-life of 12.4 years. They don't know what a half-life is. They don't know that the radioactivity issues are not the same as for fission, for nuclear power plants. So they have a lot of difficulty in discerning one from the other. And they would benefit a lot by knowing more, but not by being drowned in a lot of data that they can't put together themselves. So this was one of the issues that I think the community's got to look at in trying to get that message out a lot more clearly. Because it is a big one and it'll affect everybody.
Allan, I trust you would agree. It's one thing to
Yes, I
complete the
do.
research. It's another thing for the market to emerge with a interest in the demand for that product called energy, and in this instance, fusion energy.
Yeah.
The
Can I
promise
make a
is,
comment on that?
Sure.
In fact, I've given an awful lot of invited talks over the years to different nonprofit groups. I'm giving another one to the Canadian Club in January. And I have made it a point in doing those general talks to pick up on three things: the energy as a clean, long-term, sustainable energy source that can power everything; the environment, because we really do tackle all of the issues around climate change and pollution; and thirdly, the economy, because it's going to be a big underwriting, not only from the energy point of view, but all of the technologies that go with it, just a tremendous job multiplication and economic benefit there too. So I've made it a point in my public talks to emphasize those social aspects, if you will, from the point of view of the clean energy, sustainable, the environment, and the
okay, Mel, Allan,
economy.
for every positive, there's probably a negative. I know when we're talking about fusion today, from the research side, moving into the demand or the consumer side, we tend to ignore talking about what the negatives may well be. The impact of fusion energy on the economy that we have right now would be enormous. You want to speculate at all on what the downside is and how we need to be ready for the disruptive implications of fusion energy or abundant energy on the society that today functions on this $1 trillion carbon-based and renewables industry? It will be, I presume, very different.
It will be different, and there's two ways to look at it. Let me just pick up on the negative, if you will, and they really are reflected in what I've already said. Materials is going to be a big issue to make it work, and all the enabling technologies. In the course of, like with energy source or minerals in general, from the time you go out exploring, developing, extracting, processing, burning up, waste handling, and so on, you never get rid of that. There's always some of that to contend with, obviously. The comment here is that fusion has so much less than all other alternative energy sources that if we want energy, we're going to have to accept living with some of the undesirable aspects. And there's significantly less for fusion than any other energy source, whether it's the land you have to keep in reserve, whether it's there's two ways of evaluating it that the environmentalists use. One of them is so-called the life cycle analysis, where literally cradle to grave, what do you have to invest and process and do all the dirty deed from the beginning to the very end when you're finished with it. And if you do the life cycle analysis of all of the energy sources, fusion comes out the cleanest by far, by a significant amount. And someday, if you want, I could give you a talk and show you some of these numbers on a bar chart.
So from a future,
the second is what's called the energy payback ratio.
Let's stop on that just for a moment. So from the future perspective, if this source of energy, which has the potential to be the supplier of energy deep into the future, is clean, and the energy that we're using today is not as clean, at least as it relates to its impact on the environment, we have significant implications for climate change. Am I correct?
We have That's right. And in fact, it's all positive for environmental effects.
Okay, so
climate-wise.
that's a point which Joe Q public would understand almost immediately, because so much time and effort and energy and financing and politics and regulations is being spent today on neglect of our environment and the deterioration of our climate. Fusion has the potential, maybe from a utopian perspective, and in any case, to make the argument that we would stop or maybe even begin to reverse all of the negative impacts on what is happening to our climate. Is that not a fact?
It is true. There's still always some impact left over, but it is far less than any other energy source.
Right, and
given that we do need energy,
it's not GHG gases. That's not what you're talking about. Those are not the emissions.
No, you do not have greenhouse gases, except in the going out to find, explore, mine and so on.
So one could spend a considerable amount of time talking about fusion as it relates to its implications as a source of energy on our environment moving into the future. That topic in itself is extraordinary, given what's going on in the world today. Okay, second point. When you have an abundance of something, you have a very different market and a very different environment when it's dear or scarce or expensive or dirty. If what we have is the potential in fusion, and you mentioned we've got the deuterium at a billion-year supply or more, and as long as we can supply tritium, which is the other ingredient into the fuel, we have the potential to have what one would call an abundant supply of energy. Abundance has extraordinary socio and economic implications, particularly for those geopolitical economies today that are supplying the world with oil and gas. So what happens to Venezuela? What happens to Saudi Arabia? What happens to Alberta? What happens to these places today that are major suppliers? And what happens to the consumers that have relied heavily upon them? It seems to me we've got the potential for a very disruptive and very dynamic geopolitical event, either to prevent this from happening or defending and making the diversification in order to prepare for it. I'm going to leave it at that. I really don't want to lecture, but I'm passionate about this, the disruptive implications of a geopolitical nature, and I'll let others. Let's see. Anybody got their hand up that wants to make a comment? Jeff, you looks like you're getting agitated. You have something to add here? And you're muted. Go ahead, Jeff.
No, I was just going to say, I noticed Yogi had his hand up and so does Class. So that's
okay. All right. Thank you. Yogi, you want to go next? You're probably muted if you're there.
Thank you, Perry.
Okay.
So, and thank you to Allan for the summary description of the technology and the current status. But to your social questions, Perry, even in the absolute best case, fast rollout, super cheap energy for fusion, I think the transition is going to take a generation. And during that time, there's lots of ways to deal with the impacts on the current players that you listed, i.e. the major producers and indeed consumers of the existing forms of energy. So undoubtedly this will be disruptive, but in the course of a whole generation, I think existing infrastructure will have been amortized and can be retired, and new infrastructure can be built and woven into the rate base or the cost of products and services. I really don't see it becoming any more rapid than that. I mean,
you're being a bit optimistic about people's readiness to embrace change. I mean, if anything, we have seen the reluctance to diversify, and I think, as Eric Newell said numerous times, harvest while the sun is shining. So as long as there is still an economy in, say, oil and gas, or the production of and usage of power that has some negative implications, there are those that will want to defend the capital investment in the current economy for long after it's practical. And that's the typical cycle of new technologies.
I'm sure that is. So I'm sure that's true, Perry, but a generation, roughly 30 years, that's plenty of time to amortize whatever's there now. There will no doubt be lots of people who want to defend their position and extend whatever they're doing. We saw that with steam engines, and we probably saw that with wood producers before coal took over. And I'm sure that'll happen here. So 30 years.
Is there
not my
anything
ideal.
is there anything that needs to be done, or you just sit back and wait for pain to emerge? I can recall when someone saying to me and advised me once that change comes about as a byproduct of pain, not as a byproduct of thoughtful.
I agree with that. So let me just make one closing comment, that if this really turns out to produce super cheap energy for the planet, I think there'll be a reduction in geopolitical tensions that are related to our current energy reserves.
And I agree with you, Yogi, that given that this is 2 decades or more before we really start to see it being commercially deployed, there's lots of time to amortize. The younger generation coming up will have a very different viewpoint to the old guard as we pass away. So I see it just naturally evolving. I'm quite comfortable with the timeline and what will happen, and that it will be socially acceptable.
Hey, Klaus?
Actually, I was going to say the same thing as Yogi, is that one of the pluses actually is the fact that we don't yet have fusion. We have a process that's going to be very complex. It's going to have some real challenges, some real opportunities, but we're not quitting cold turkey. Just because of the announcement that was made now, or even when the first pilot or demo plant brings its first energy onto the grid, that's still a long ways off from being completely the only source of energy that there is. So that there will be a natural progression while we have time to adapt to things. And we're doing that already. We're electrifying a lot more things that are now using fossil fuels and those type of things. Again, if it was cold turkey and all of a sudden all the oil was gone tomorrow and everything was replaced by fusion, yeah, markets would collapse and there would be riots in the street. But we don't have that. We have time. We have time to see what way to go, which one of the multiple ways are going, or maybe multiple places of doing it. But ultimately, the end goal is positive. And even one of the questions that's coming in now is, well, should we be spending money on fusion because we can do it all with PV and wind sort of thing, and we're already done with it? But there's even there, when you say, yeah, maybe they're late to the party in terms of getting to net zero, but there's the other part is, how do we get the extra carbon out of the air? And if you've got unlimited fusion or unlimited energy, you can start pulling it out, using that energy and making the climate even better in terms of moving forward. So I don't see too many negative things other than people unwilling to change over time. And they're just going to be made irrelevant because the new way is superior to the old, and it's just going to disappear.
So I want to compliment you bringing to the surface advanced electrification. I mean, we're already seeing that well underway, and it would seem to me that as fusion emerges as a positive, you have a source of electricity that would help advance electrification. Peter, you have a comment you want to add here?
Thanks, Allan, for a very interesting presentation. I was just wondering about, of course, the ignition facility at Lawrence Livermore is, as you've said, a science experimental tool. So can an ignition facility, you think, in the future produce continuous supply of fusion energy? I mean, this is like 160 some lasers and fills a football field of space. That's just one experimental facility. If we're going to scale it to production, how would this type of technology work for confinement and production of fusion-based energy?
The answer is twofold. One is the way in which Livermore has set things up to do their scientific investigations could be one way to move on to commercial production. But to do that, you would have to have higher rep rate laser systems. So where this is a shot or two a day, you'd have to have it happening 10 times a second. There are other schemes, however, that would say, if I build little higher energy lasers, I could do it only once a second. And in fact, that seems to me to be a better way to tackle it from an industrial commercial point of view. And there are schemes for doing that. So the first answer to your question is everything has to be scaled up. We need more efficient lasers. We need them rep-rated. We need enough energy and repetition rate to give you the input power to sustain the output power. But it can be done, and people are working on the scaling of those technologies now. Another approach to the Livermore one is to say, and it would be more efficient in the first place, would be to take the pellet and irradiate it directly with the laser beams rather than doing what they do, which is converting laser energy inside a gold can, converting laser energy to X-rays, and the X-rays do the work on the target. If you just irradiate it directly, you'd improve your efficiency tremendously. But the big thing is you need more efficient lasers to begin with, but we already have that technology. We can build lasers today with 10 to 20% efficiency compared to what Livermore had when it built that facility as a scientific tool starting in the 90s. It was like 0.5% efficient. So we've got a multiplier of a factor of 20 to 40 already in what you could build with lasers today. So I'm not worried about the new technology, scaling that up and rep-rating it and reliability and so on. Those are already a work in progress, and we certainly need them for practical fusion devices.
But today, Allan,
Thank you.
the power sources that light up our cities, for example, are typically located initially at the site of the coal field or the site of the hydropower. With fusion, it seems to me, one, it's safe. Two, the potential is that you'd actually be locating your plants closer to market, and you would be using your existing infrastructure, which is another positive because it's electricity that's the byproduct of fusion energy. Those seem to me additional positives in terms of the implementation and the journey there, is we don't need to spend a lot of money on associated infrastructure as we would with hydrogen, for example.
That's an important point, Perry. With safety, we could actually house these plants right in the middle of a city. And with all conversion of energy, as you appreciate, current electrical production, we get 30 to 40% efficient with our electrical steam generation systems. There's always waste heat, no matter how you do it. If I could put it in the middle of the city, I could use that waste heat for public heating, buildings and so on. So we can make things a lot more efficient overall.
So with those that are sort of shaping a reassuring scenario, and I hear, and I'm delighted to hear that from a positive perspective, what are the ramifications for Canada? Is there anything quite unique about fusion or unique about Canada that would give us an advantage in a global fusion market?
We already make heavy water at great cost to the taxpayer. Sorry, I meant deuterium, not tritium.
Oh, sorry, deuterium. But we also produce, I think, at Chalk River, tritium. So we could become, as we are in the oil and gas industry, a major supplier. Is that possible, Allan? Is that realistic? Is that probable?
We can be a supplier, but you have to remember, let's imagine 50 years from now, we have a lot of fusion power plants around the world. Each of them is going to need so much fuel compared to what our CANDU reactors produce that we could never begin to supply the world's need of tritium for all the operating systems. In fact, each system is going to have to produce its own fuel. And fortunately, you can do that because of the output products of fusion. There's helium and there's neutrons. And the neutrons can be made to interact with a lithium blanket. Note, lithium here, we have lithium ion batteries. That's not where I want to see the lithium used up. I want it reserved for fusion because the neutrons and lithium can generate tritium. So if I imagine fusion reaction neutrons coming out into a circulating lithium blanket, and then we process the tritium out of that lithium blanket, we then generate our own fuel. And in fact, to sustain, in the long run, to sustain practical fusion plants, they're going to have to produce most of the tritium themselves.
Okay, well, associated with this topic is, does fusion and the generation of fusion have any ramifications on the amount of radioactive materials that have been generated in the world today by fission?
If you take the tritium hazard as we know it, and it's been around for a long time, so there's a lot of knowledge about tritium handling. In fact, it is less of an issue than the radon, and we're all aware of radon living in our homes in Canada and basements and so on. There's more hazard with natural radon and natural radioactivity than there is with tritium, such that if you imagined a power plant with tritium, suddenly totally, the inventory of tritium totally released to the environment, you wouldn't have to worry about living next door to that plant. The public just wouldn't get enough of a hazard to worry about it. So there is tritium, but it's not hazardous except in the form of tritiated water, where if you drink the water, now you've got that internal emitter taken up inside the body. But ordinarily, tritium as a gas is not an issue. And as I say, it could disperse and you wouldn't have to worry about that. And you've got bigger radioactive hazards, radon and so on for natural and atmospheric as well. So I'm not worried myself as tritium, but it is there. You have to be conscious of it. And in the course of actually producing it and processing it for the internal operation of your fusion plant, that's where you'd want to be careful not to have losses, because A, it's precious. You've got to preserve all of it to have an economy, a fusion energy economy. And for two, you wouldn't want people exposed to the tritium in the course of doing that processing at the plant.
Did you comment on the capacity of fusion energy plants to actually use radioactive material to complement the fuel? Is there any value in the radioactive material that the fission industry is producing?
Well, if I could back up, my envisaged future is we're going to harness as much as we can of renewables, and that's all of the renewables along the way as we can. We're going to have to go to nuclear fission, small modular reactors, whatever. We need fission because we can't do it alone with renewables. So we're going to be going to fission plants more and more coming up to the mid-century. In the long run, I see fusion as that main power source, but along with the energy, you can actually use the neutrons from fusion to clean up the radioactive waste from your fission. So let's imagine we have a few decades of fission plants running and the public is still concerned about how do we handle all that radioactive waste. Well, when we've got our fusion plants, those neutrons can transmute all the radioactive waste that have been accumulated. So there's a virtue to this whole cycle in many different ways.
Hey, Peter, do you want to further that discussion?
Thank you, Alan. Thank you, Perry and Alan. Yes, well, you just sort of answered my question partly, Alan. I did pose in the following way. Do you see any argument to go fusion versus fission by 2100? I'm thinking of that as sort of the Paris date. Because and then will there be a competition with each of these technologies once they're both commercially scalable, that SMRs, for example, and fusion capability?
I'll back it up. If you're saying 2100, I'll make the case we'll have fusion as the main source by then. The question is, how do we get to there, and how do we get to what we need by 2050? We're going to need fission to help us stop burning fossil fuels before 2050. And fission is a technology we have today to employ. Fusion we'll never have enough plants built out to satisfy our needs by 2050. It'll become important in the second half of the century and certainly by 2100, but not initially.
Well, of course, a fusion and a fission, I guess, both are making either heat or electricity. And what about mobile needs for energy with a fusion world?
I see a mobile world two ways from fusion. So put your fusion power plant at the center, that it most of all starts out by just producing heat. So for all our industrial processing, we've got heat as an emergent. Secondly, we can use that to create electricity, and we will do that. And electricity will run our EV mobile system that we're building out now. In addition, once I've got high temperature fusion, I can more efficiently produce hydrogen. And so I can go to fuel cells, and both for mobile and stationary fuel cell application, I've got the hydrogen production from fusion too. So I see an integrated energy economy in the long run of fusion, heat, electricity, hydrogen production, handling all of our stationary and mobile application.
Excellent. Thank you.
That's an excellent journey, and I think you've laid out a number of the milestones along the way. Klaus, I'm going to pose the next question to you. I know you've been a student of how Europe, around the ITER experiment, has in fact been putting a lot of suppliers together to feed that plant, and that those suppliers will have a significant impact on their overall economy. What are the economics of a fusion energy plant for the local or regional economy?
Well, I think it's as Allan said, is that we've got this huge complex machinery to be built, and none of that has been done yet. I mean, if you look at Buckminster Fuller, when they talked about critical path to getting to the moon, and a number of things that in 10 years they had to come up with that were not invented yet or weren't set up yet. So a lot of it comes down to scale. I know in Europe, one of the things they've done is they've put little, the businesses that they needed, the makers of the lasers, the isotopes, all those type of things, and used them as an incubator to move forward. Allan was saying we need new materials, we need fuel supplies, manufactured components, and these would be high precision type of things. Those are all things that are going to be needed as we move forward, but we got to make sure that we're on the right path and we buy the right materials at the right time. But there's huge opportunities, and we don't even know what those opportunities are going to be, because it's not going to be the opportunities we're using now.
In various meetings that Allan has had, and some of them I've accompanied him, we run politically into the reluctance of the politicians to be forward thinking. I mean, they get votes based on what the public is wanting today, and the public is unlikely to give votes if you're talking about some grand vision of the future. Is Canada ready? Is the public in Canada ready to support the directing of taxation, or the directing and the shaping of regulations to create incentives for Canada to get ready for the fusion world? Or are we going to be one of the last to the party, given our defensiveness around transitioning the oil and gas industry?
The misuse of the regulation to ensure that we take a high cost, low results approach to the much discussed energy transition does not give me a lot of confidence that we'll get the regulatory environment right for fusion. We certainly can't seem to get it right for the climate change / energy transmission. So maybe I've just burst my reputation as being being very positive.
Is there anything you would recommend that we might do?
As a capitalist, I think we should ask government to sit on their hands and think just about public safety, if there are any public safety implications of all of this, and stop there.
Okay, so that would be taking a defensive approach. Allan?
Yes, I'll make a comment that hopefully will make you feel a little better, Yogi. And that's the powerful influence of international affairs. And let me pick up on the case that I mentioned. The US now is getting foursquare behind fusion. As part of that, if you're going to go out and start building these things very quickly, you'd better have your regulatory system in hand. And so the Nuclear Regulatory Commission in the US for the last 1.5 to 2 years has been looking into how are we going to handle fusion, given that they already have responsibility for fission.
Right.
And there's been a lot of meetings. I've been attending these Zoom meetings in Washington. What's coming to bear is international pressure, because the UK has come forward and said, we want to be a leader in fusion, have put a lot of money into it. Moreover, did their nuclear regulatory function beforehand. And what they've come out with and said, fusion is so safe compared to fission, we don't need a nuclear regulatory body looking in on this. We can use our normal industrial safety health standards for all business and industry that gets generated in the country. And they've already laid out their policy in the UK on that basis. Well, this has already been fed back to the US, and I'm sure you'll find in the next few months that the US too will end up using very straightforward industrial policy for health and safety, not the heavy-handed multi-decade approval fission schemes that we've been living with for a long time. And states have already intervened in the US, and because they have various federal state ways of handling all of this, of course, and the states have weighed in and said, yes, we don't have to handle fusion anymore with any more difficulty than other existing health safety on business practice. So
Yeah.
I think we'll get by that one very soon.
Because that's comforting on the regulatory side. Ron Main, unmute. You have a comment or a question?
Yeah, thanks, Barry. I think the Alberta government should be stepping up here. They're putting quite a bit of money into climate change and energy transitions, hydrogen. We've got a lot of wind and solar here. I think they should be getting on the bandwagon for an SMR fission reactor in Fort McMurray area, so that we can reduce the pollution created by generating the oil and gas stocks. But the key thing that they need to do is to put subsidies in place so that all of the engineering and precision manufacturing and machining and construction for this has an advantage over outside companies, so that we can develop those skills inside the province here. And then in 10 years or 15, 20 years, when we start building the fusion reactors, we'll have those skills here in the province. And that's about the time when oil and gas probably will be declining for as an energy source. So I think what we have to do is get on the bandwagon and start supporting it right away. Thanks.
It's a very interesting perspective, because you're portraying fusion as complementary, or nuclear fission on the way, as complementary to the oil and gas industry as sources of heat, which are needed for extraction, and instead of using natural gas. Allan, you're well aware of a study that was done a few years ago along these lines. Do you want to comment about that study?
Yes. And just backing up to the fission side, first of all, even earlier, there was a study commissioned looking at fission reactors as a source of heat. This is pre-SMR days, but a source of heat for doing the oil sands extraction. And the basic reason that it wasn't accepted at the time is that fission tends to run at a very low temperature, a few hundred degrees, sort of call it a little room temperature plus. And that doesn't give you very high quality steam for propagating for underground application. So fission was not accepted at the time. They're now redoing that looking, I guess, with SMRs on the basis that you would try and run a higher temperature cycle with SMRs for doing that application. But let me turn now to the fusion then. Fusion automatically starts, you're going to be up at 600 and 700 degrees with your system circulating outside. So you can go into critical steam applications and all the other things you have to do in multi-stage for energy extraction and power generation. So fusion starts out first of all having a much higher quality of heat available. what we did years ago is commission a high-level study from Lawrence Livermore National Lab, asking them that if the fusion reactor based on the laser fusion was working today, how could it be applied to the Alberta scene in two respects? One for heat in oil and gas, and two for electricity. And we had the oil sands people and ATCO and others in the power generation. And so we got this high-level study done from Livermore. And the oil sands people asked for, could we have everything from 100% heat to 100% electricity, or hybrid combinations in between? And the study came out and said, yes, if you had a fusion plant today, it could do all of those things very effectively. And you could either have your heat and get electricity on the free, or the other way around. There was a very wide scope of economic advantage to having fusion as that heat source.
One of the sidebar points made in the chat, Allan, was the relationship at Lawrence Livermore of their fusion experiments to the military, where I think it's 85% of the funding really is with a military objective. That, of course, from a point of misinformation, could be a point of volatility come the public. Is Lawrence Livermore, or is the United States likely to start transitioning to either putting a different plant together, a new plant, and or modifying that relationship of military to commercial?
Yes, it will, and in two respects. One, because the commercial pressure is already emerging. When I mentioned this one company that I'm involved with, in fact, they are preparing a proposal that's today or tomorrow to go to the Department of Energy for co-funding. So the pressure is coming from the private sector to move this into the commercial domain. Secondly, even Livermore, while their mandate in the first place was building lasers to do the weapons reliability issues, that's why they got into this. Nonetheless, they too have now established an office for inertial fusion energy. And obviously the idea will be able to take everything they've learned, and through licensing of intellectual property and so on, they'll be able to be a participant in the transition to the commercial side of energy, while still doing what they have to do at the lab itself for their NNSA applications. So the pressure is twofold: from the lab and the scientific capability to move it out, and secondly, the commercial moving along and coming in.
There's obviously a number of points here that are sensitive. The militaristic dimension is one of them. The radioactivity and the relationship of fission to fusion and how they differ. Public communications on the relevance, the safety, the cleanliness, ultimately the affordability, the timelines, the geopolitics of who's going to be first, and is that party that's first going to be monopolistic, or is the technology associated with realizing fusion likely to be in the public domain? This is all part of what will be needed in order to prepare for the future, prepare the public for the future. Change agency is usually about prepare the people, prepare the community, and develop the infrastructure. It seems to me fusion would be wise to start giving thought, not to when the market emerges, but to anticipating that market. But that's an investor's choice. I am very curious as to where in the world today. It's all well and good to have heard the announcements coming out of Lawrence Livermore. That's certainly exciting. And it's nearby because it's in the United States. But I understand China is moving rather rapidly in terms of its approach. I don't know where Russia is. I know that Europe is collaborating in terms of the ITER initiative. Do you want to comment at all on the international race to fusion, Allan?
Yes, and it goes back to fusion being declassified in the 1950s, in fact, that really got the world working cooperatively on developments. And that's turned out to be good because the problems have been manifold. So you want all the bright minds working on it. Anyway, for decades, fusion has been in the international sphere in a collaborative way. And in fact, this ITER project that you made mention of, Perry, that's being built in Cadarache in France. That's like a $22 billion project underway, not yet finished. But that was instigated between Reagan and Gorbachev back in the 90s as a way of getting Russia and the US working together on something for the future. Well, in spite of all the things going on now, Russia is still a partner in ITER, and they don't want to give that up. So the world has learned to cooperate in some important ways, and fusion is one of them. Fusion, and certainly through my whole career, it's been wide open. I have spent time as a visiting professor, guest professor, consultant in Europe, in Asia, in the US, and the doors have been pretty wide open to just engage any and all expertise that comes along. So I'm pretty confident about that. Where it will separate, of course, is in whatever 1 or so decades, when individual companies come forward and now want to put patents on certain ways of doing things, and then you'll see the things closing up shop as they try to extract a commercial advantage. But for the moment, there's a lot of information out there and open to cooperation as well as competition.
So this,
And China, just coming to that for a minute, a comment I'll make is that China came in late into the fusion game, but I would say they have caught up to the world. They're completely competitive in fusion, and in some areas they're moving ahead. And the most signal way they move ahead is they can build anything cheaper, faster, better than anybody in the world. Where it takes us 10 years to do something, they do it in 3, and the damn thing works. So look for China to be a real competitor in fusion in the long run.
does the concept of friending come to play in here? I mean, you commented on collaboration in the early stages of fusion, trying to make certain that this is a global opportunity and that all have the opportunity to participate. That's called friending. It seems to me that if you're not going to be first on technology, you could be first on the collaborative side of providing leadership to make certain that everybody's in the game. I recall when I visited Lawrence Livermore, the effort that they made to make sure that every state was involved in some aspect of supply of that project. 50 states were behind that initiative. It would seem to me Canada has a unique opportunity to play a leadership game. And I point to you, Allan, and what you've been doing internationally, because you're not viewed as a competitor, and Canada isn't viewed as a competitor on the technical side. That one of the unique roles that Canada could play is to be that collaborator, that body that provides the leadership to ensure that all parties benefit on both the production side and ultimately on the consumption side.
That possibility exists for sure, but you've got to put your foot in and be recognized as a player. And Canada right now is not that. Back a long time ago, in the 80s, the National Research Council did a major proposal, and I was on that advisory body for Canada to get a national program going. It did get started with Atomic Energy of Canada at the time administering it, and then in the 90s, the Canadian government decided to drop out, and we've not had a national program ever since. So the first thing is, if you're going to become a player, you've got to be engaged, and the comments of others already that why isn't Alberta stepping forward and making Alberta a player?
Well,
we need a Canadian play situation, because then, yes, we could be one of those in the middle players, as you say, Perry.
But we did hear from government that government said, can you bring industry into the room? They said, you're knocking on the door and you're asking government to do something. We want to see that industry is prepared to play the game. The reassurance that Mel brings to the table, and I've heard throughout this session, is that this could be a smooth transition as organizations get ready. Is it conceivable that Alberta, given its extensive involvement in the industry, could take a leadership role, even though the long-term implications may be negative, and facilitate its own diversification? Could Alberta play a leadership role here by bringing industry to the table?
Well, the answer is yes, but even more, we need the national government involved, because if we're going to do table-to-table stakes with the US and Europe and Asia. You need people at the federal cabinet level talking to each other.
So you're not
So you,
championing
you can't
sovereignty.
you
I
can't
wouldn't
bypass.
go with
We first and foremost need a national program under which the provinces then sector out what they can contribute. Yeah.
Well, that sounds different than sovereignty. It sounds like collaboration, but let's not enter into the real geopolitical. Greg, did you raise your hand or were you coming to a laugh there?
A little bit of both. You stole my thunder on collaborative leadership. I think that's an asset we have.
Yeah.
We also understand energy, upstream transmission, downstream
Mhm.
production, consumption in Canada, probably, and in Alberta in particular. The ability to bring many stakeholders to the table, something I think Canadians do well. If we use the military experience of Canada, I know we've lost our way as many countries have in the last 10 or 15 years, but Canada was never a heavyweight militarily post World War II. Yet we built bridges around the world. We brought people together. We advanced peace. We did punch above our weight because of our ability to work with others. So even though we're not technically at the table, you look at the space shuttle, the Canadarm, for example, that was a pretty important piece of infrastructure to bring to the space shuttle program. I think we can bring that collaborative infrastructure forward. I'm convinced we can. And
so that would be, it's one thing to invest in research and technology, it's another to invest in process. And the processes that, and I'm talking the geopolitical processes associated with bringing a technology to bear are critical and could play a major role. As this discussion goes on, that's a scenario in itself that Canada differentiates itself by advancing the fundamental processes to enable us to take place in a just and an equitable way.
Can I quote our friend Axel Meisen?
Sure.
In a Agriculture Alberta strategic foresight strategy development exercise, keynoted at the lunch, and he said the future would be defined by the social sciences, the soft sciences, not necessarily by the physical sciences. So the word I would put, I kind of hate it, and would welcome a better word, but two words I put to it: we need some social innovation. And I think we're ahead of the curve on that as well.
Well, I know we do have Alberta, thanks to you and your co-founder, the Alberta Canada Fusion Energy Alliance, now Fusion Energy Council Canada. We do have a vehicle, an advocacy vehicle, and while its attention is very much on the science and technology side, its mission certainly reads as an advocate for fusion, and it certainly is here in Canada. So I look forward to hearing more from that council on the role that it could play in ensuring that Canada plays a leadership role on a global scale in this endeavor or in this transition. Klaus, do you want to add anything? You've been a student of this now for a good 10 years. Anything that we've missed that you'd like to raise?
No, I think this has been pretty broad ranging and very positive in terms. And I think there was kind of a catalyst last week with the announcement. I mean, when Allan and I were going around the world looking at where all these things were, we thought that announcement was going to be made about 9 years ago, sort of thing. And it's taken long. And as Allan likes to say, you can't do science on a schedule, sort of thing. It's set up. But one of the things I did learn during talking to the other countries and the other people that are doing that is that Canada has a very good social reputation. Nobody gets, if you can't get along with the Canadians, who can you get along with, sort of thing. So there is that brand that we could work with and say, we can help. We have nuclear technology. We've never weaponized it, hasn't hurt us, and we've got the technology to do that. We can do the same with fusion and that sort of thing. So we can bring people together. So where there's pieces that may need to be linked or need to be put together, I think that's a real skill of the Canadians.
Well, at the risk of getting somewhat more concrete, I'll ask Greg, do you want to comment on that? Is there something that we could be doing now in order to elevate the role or develop the role of Canada as a leader in these processes?
There are collaborative processes that we've developed here in Alberta, Canada, that have been called as superior to what Stanford university has developed in its collective impact infrastructure, which is the gold standard in the world. So we do have some things to build on. We have a great council, Fusion Energy Council of Canada, with a great vision and mission, which positions that organization not only to advance technology, but to advance fusion and all it can be into the world. And the third thing, as a strategist, I absolutely loved Kennedy's vision to put a human being on the moon by the end of the decade. To me, that's among the strongest vision statements ever articulated because it put a time frame on it. And if I think, if I would bet my net worth that he hadn't put by the end of the decade on that vision, we might not have even reached the moon today. So we have this imperative from the White House to get busy, get going. And heck, we don't have to be the best at social innovation. If there's people that, the thing about social innovation is you're not investing in pots and pans and lasers. You got a better way? Let's do it. So it's collaborative and actually unto itself. By you have a better way of doing something, let's do it better. And it doesn't require anything but a few changes of words.
But it does seem to me that as a catalyst, you want to trigger something that is ongoing and broadening. And that while this might be a toe in the water, and that was my intent, was to initiate a dialogue on the social impact and what might be done to keep this dialogue going on something more than just the science and technology, but more on the preparedness. How to go about doing that. I mean, we can do webinars weekly, we can release newsletters as FECC is certainly proposing, but those tend to reach quite a small segment of already well interested or well invested or already employed individuals. It seems to me getting Joe Public to get excited and stay engaged in some way, and their students to be looking for what they can learn in order to be ready for this new event or help transition it would be of value. Ron, you want to add anything here?
Yeah, I want to go back to, I think Alberta can be a leader in this. And yes, we do need an international presence, and that takes the national government into it. But perhaps Alberta can shame the federal government into doing a little bit more. And with respect to nuclear energy and the oil and gas industry, I don't see nuclear energy really as a negative there. The earliest we're going to be getting an SMR is close to 10 years. Fusion is 10, 30 years out, but peak oil is about 15 years out. And after that, we're still going to need lots of energy for the oil and gas industry, because so much of that, more than half of it by the time we hit 2050, is going to be in petrochemicals. And so maybe we're not using oil and gas for energy international, but that doesn't mean that we won't have an oil and gas industry and that they won't benefit from nuclear fusion or fission.
Excellent points. I mean, I can see the shaping of a scenario where that pathway has a number of stages and a number of participants in it, all of which have opportunity and are reacting not to threat, but to emerging opportunities and the foresight of getting ready now. It does seem to me government does play some role in here, and that partnership between industry and government will be critical, that there are, if not regulations, because it sounds like that's not the issue, but the creation of incentives as they're doing for electrification, that the creation of incentives for industry to start getting involved in this sector, in the production of lasers or the production of the pellets or the research into tritium, that if we had incentives as it relates to preparing for the arrival of fusion, that would be a considerable benefit for the industry globally and for Canada specifically. Allan, do you want to add anything there, or
any and all opportunities should be exploited? I've been around this, as you know, Perry, for a very long time, and at various stages with different proposals to the Alberta government to move us into the ranks of what's going on. It never materialized, but I would, and in the past, I've also met, going back a long time ago, Eric Newell and others in the oil and gas sector in Calgary. I met with a lot of them at the time, pipelines and everything in terms of those future opportunities in fusion
Mhm.
and trying to inveigle interest on their part. Maybe it's time to revisit those meetings, have a discussion again with some of the senior leaders in the oil and gas sector and the provincial energy department, to just a sit-down session. What could we collectively think of doing now that fusion is getting so much international news, now that we know things are strongly moving ahead? How might Alberta position itself and take on some leadership? Maybe it's time to just revisit.
I'm going to sit down with you and we're going to talk about bringing Eric and Jim to the table. They were clearly very strong on the relevance of decarbonization and recognizing that decarbonization is underway. It's real. We're buying in. Let's see whether or not fusion finds its way to the table now. Barry, yeah, go ahead.
I have a recommendation of someone you know that is very much in tune internationally with all things energy. Born and raised in Edmonton, living in BC now. He's a senior fellow at the MacDonald Institute, and his PhD, which he got within the last decade, is from the University of Kyoto on energy policy in the Pacific. So if you want somebody, I would strongly recommend you include Jeff Kaharski.
Oh, yes. Well, Jeff participated in the decarbonization series, and no question, he's highly regarded and quite articulate and well-versed in the decarbonization necessity and what can be done about it. So right on. I'll reach out to Jeff.
We're talking about billions and trillions of dollars of investment over the next 20 to 70 years.
Yeah.
Engaging people are literally neutrons in the bucket of that expenditure. It does not cost money in this day and age. What did it cost you today, Perry, to bring these people together to promote this event out to 20,000 folks? One of the gifts of COVID is to digitize everyone, and everyone can do a webinar. We don't need a big bang either. We can have a series of online conversations that are ripened over a period of time. Ideas can ferment over time. The stew gets better. The stew is always better a day or two down the road. So we don't need to look at social innovation and engagement in the same hard capital, where's the money coming from paradigm as we do with hard technology.
You walked into something that is a principle of which I adhered to when I was in management, and that is, in order to get support, hit them high and hit them low. And we've been hitting them high by going to government and trying to get those at the top, but we have rarely built a constituency in a democracy of demand. And I think what you need to do there is prepare the people, and that means inform and communicate. As we saw in the newspapers the last few days, it is now public that people have heard the word fusion and understand it's different than fission. They may not need to know what goes into the engine. They may not need to know what holograms are and pellets, but what they do need to know is that there is something coming that will have significant implications on a personal level. At the electrical outlet, in the garage, and in terms of the configuration of what cities may look like in the future. I think in that regard, you can get the public engaged, and because they don't feel stupid. They can relate to their lives and how fusion may have an impact on their lives and their jobs. They may want to hear what the negatives are and what is being done in order to mitigate those negatives as it relates to jobs and economics. But what you touched on, Greg, I think is fundamental for a strategy that has both a hit 'em high and a hit 'em low perspective. And that certainly complements what government in a democracy looks for, is either bring me industry and or bring me a market. And that's your public demanding that we get ready and we prepare. Klaus?
Everything that we're trying to communicate has been talked about here. So it's great to hear that the discussion is happening. We can take a book out of I was involved in the early green building movement and that sort of thing when nobody was talking about that. And one of the things that always stuck to me was that politicians don't lead. They scan the horizon for parades that they can get in front of. So our job is to make a parade. Let's get a parade going and that sort of thing. And that's through discussion, through exactly what you're talking about here. The reason I raised my hand was that it occurred to me, if you're going to engage with the oil and gas industry, as an icebreaker, maybe talk about carbon capture and storage and hydrogen. They're really big on hydrogen and getting green hydrogen. Right now, they can make blue hydrogen from natural gas, but ultimately you want green hydrogen, and we don't have enough materials to do that. So the only other path for them right now is carbon storage, which is a very expensive and very long-term thing. So it might be interesting just to compare, if I was going to invest $5 billion into a carbon capture facility, what would it get if I took that money and moved it into a fusion play? Is that something you might not do it today? Maybe you could do it a couple of years from now, but that might be a way to start the conversation. So you have something solid to compare.
Well, your comment there dovetails very well with the point that Randall Edcock just brought to my attention, and that is we do have in Alberta what's called the Emissions Reduction Alberta. That body looks at the transition from an oil and gas industry today that is not viewed as clean to becoming cleaner. It's not just oil and gas, it's sources of power.
Yeah.
Wind, solar, and in this instance, fission and fusion in particular. Maybe in this future webinar that we're envisioning, we bring Justin Reimer to the table, or we meet with him independently to have a discussion about whether or not fusion is on the table. Okay, well, I have 40 seconds before 5:30, and I did commit to wrapping it up at 5:30. We've had just exactly what I was looking for in the concluding, 15 minutes or so as we started to transition into what might be done in order to take advantage of the catalytic role that this recent breakthrough announcement has triggered. One of the ways would be to keep this webinar series going, but secondly, to look at, as Greg has mentioned, ways to get more and more of the public involved in the discussion, engaged, not just as passive listeners. So I want to leave that to Greg to share with us ideas, but I'm also going to challenge everyone who remains with us today that if you have ideas, share them with me. So I have no further comments to make other than a summary of thank you very much, all of you, for attending. Peter in particular, from out in Ontario, Barry down in Canmore, Clayton here in Edmonton, Claire for being an administrator and help us get this going, Randall with your ever helpful perspectives. Peter, I was hoping you might be bringing forward someone from Calgary with your continuing interest in scanning the nuclear social media for me. Let's keep that avenue open. We'd be delighted to bring in some additional representation from Calgary. So without any further ado, I want to thank all of you, Allan in particular, for your introductory comments about production, and all of you about the ramifications of fusion energy on a changing economy and our future.